All right, so this is notes video 2, and we're going to do operations with that scientific notation stuff that we did yesterday. And so here's the tricks. When you're adding and subtracting, we have exponent rules. And so our exponent rules, remember, if they're the same, if exponents are the same, you add the coefficients, which means the number. Make sure you know coefficients is equal to the number value. Do you guys know that means number and not hashtag? Okay. If you multiply, multiplying the front, you add the exponents. That's the same as our exponent rules. All right. And there's a yellow piece of paper in the front of the classroom that tells you that dividing is subtract. And so those are some things that you were supposed to learn in Unit 2. Adjust the exponents as necessary so that the coefficient is greater than or equal to 1 and less than 10. What that means is you always want 1.4. You can't have 10.4. That's not allowed. All right? So you always only have one number in front of the decimal. If you have this is wrong. You have to move it so there's... All right, now with this slide, make sure you read the directions. It says convert to the correct standard notation. So what I would do is just 1, 2, 3. This is 3, 4, 6, 7, and I'm going to need that 0 there. That is the correct standard notation. 1, 2, buckle my shoes. All right, and so this is just you writing out the whole thing. And so that shouldn't be difficult. Actually, if we go back quick, make sure you understand the correct scientific notation is this. Because if I would have put this decimal here, 1, 2, 3, 4, this is the correct scientific notation. This is the correct standard. Pretty similar here. We got 3.2523 because I could write that down right away. This decimal would have had to go right there between the 3 and 2 because I left one number out front. So that would have been -3. So what I have in red here is the correct standard notation, and this is the correct scientific notation. Because you guys should be really, really good at finding some of these. And 1, 2, 3, 4. So 3, 5, 3, 2, 1, 0, 0. Correct standard notation. 1, 2, 3, 4. So I got to add in 3 zeros. So 0.000 0, 0, 0, 0, 2, 3, 4. So these are the two correct standard notations. Now I think what I like you guys to know is that this is 3.5321 right when I look at it. This is 2, 3, 4. Because these are the only numbers in there. And then it would be times 10 to the negative and times 10. So if I move this back in, 2, 3, 4, 5, 6. What I have in black is the correct scientific notation. The first ones that they give us, 4, 5, 6, 7, 8. All right, these ones that they gave us up here were not in correct scientific notation because there wasn't only one number in front, okay? Now there's only a 2, there's only a 3 here. And so that's how I know it's correct. I messed up. Leave your answers in scientific notation, all right? So on a calculator, what I would do is 4.57 plus 0.37. That is 4, carry the 1, 9, 4. Times 10 to the third. With addition, it is super easy because these decimal points, see how these decimal points line up all the way across, are lined up because they're both 10 to the third. And so I don't have to worry about changing anything. I just have to add straight up and straight down. So on a calculator, what I would do right now is 2.37 and then times it by 3.47. So 2.37 times 3.47. So when I do that, I get 8.2239 times 10. Now, somewhere in your brain, you were supposed to know that when you multiply exponents together, like x to the 4th times x to the 7th, I told you all the time that combines to be x to the 11th. It is same for scientific notation. That 10 is like a variable, and so you just add the powers up. All right, 9.6 in a calculator divided by 1.6 is 6. So this, divided in a calculator, you get 6. So I'd probably write 6.0 times 10 to the, somewhere, we talked about 10 to the 7th over 10 to the 4th, that there was 3 more 10s on top. All right, and so we were subtracting. So this is times 10 to the 3rd. So you are subtracting when there is division of exponents. Now, this is finally one where these two things tell me that the decimal is not going to line up. And so what I'll show you is 1, 2, 3, 4. So this is 48200. And this one is 1, 2, 3. So this one is 3450. So what you should see is if I would have tried to add or subtract those green decimals are not lined up. So you can't use them. Okay, so you got to do this one by hand. I think if you look at this, you'd have 0, 1, 5, 7, 1. So you had 7, 4, 4. And then your decimal was here, since we multiplied it out, and we'll just do it the long way. And you go 4.475 times 10 to the 4th. Okay, and so when these decimals, when these values aren't the same, you got to multiply it out. Okay, making the decimal goes here and line the decimals up. All right, so these two are a little bit easier because now we're just doing exponent rules. So multiplication exponent rules, 6 times 2.5 is 15 times 10. And then it's supposed to know 3 and 2 make 5 because you're adding them together. Now, this one's wrong. Technically, the decimal is here. I would want it here. So the answer here to get the correct one is 1.5 times 10 to the 6. If you needed to, you can multiply this out 5, which means when you come back in, you'd have 5, 6. 7.8 divided by 1.2 in a calculator. So if I do this in a calculator, I get 6.5 times 10. 8 minus 4 is 4. Okay, and so I'm going to stop now. I think that's a good review, and you guys can come up with questions.